So today I will talk about how spherical polar components of velocity written in the form of Cartesian components. Right, that's what we are going to do. So let me write down that what we are trying to do right now. So as we know that VR is a radial component, so it is basically r dot, and similarly this v theta and b theta can be written as r theta dot, and v phi, this is third component, and it can be written as r sine theta phi dot, and where r dot, it can be written as means xx dot plus y dot plus z dot divided by r, and it can be written as xx dot plus y dot plus z dot and divided by r is basically x square plus y square plus z square under the root. And this another component r theta dot, this can be written as xx dot plus y dot z upon rho and minus z dot rho, and whole divided by x square plus y square z square whole under the root. And here rho is equal to, this rho is x square plus y square under the root. This is the relationship for this, and sometimes it is also written as r sine theta, right? And what is r sine theta phi dot? It is equal to x y dot minus y x dot divided by the x square plus y square whole under the root. So that's what we have to prove now. So let us start with the Cartesian coordinates and their relationship between the spherical polar coordinates. So as we know that x is equal to, it is r sine theta, cos phi plus this is y is equal to, it is r sine theta, and sine phi, and what is z? Z is equal to r cos theta. And let me try to find out x dot, y dot and z dot. So how x dot can be written? For x dot, it is, first of all we have to take the derivative of this one, so its derivative with respect to time is r dot, and I will apply the chain rule, and this will remain as it is, then first will remain as it is, and the derivative of this one, so it is derivative of this is cos of theta, and derivative of theta will again theta dot, and cos phi will remain as it is, plus sine I will apply it later on, and then r sine theta will remain as it is, and again the derivative of this, will be, cos will be sine phi with the negative sign, and I will put the negative sign here, and again derivative of phi, it is phi dot. Similarly this y dot, it can be written as r dot sine theta sine phi plus r, the derivative of sine will be cos of theta and theta dot sine phi minus yeah, it is plus, so r sine theta cos of phi and phi dot, and here it is z dot, it can be written as yeah, r dot cos of theta minus r sine of theta dot. So these are their derivatives. So what we will do, we will try to find out x dot first of all. So what is x dot is equal to r sine theta cos phi into r dot sine theta cos phi plus r cos theta dot cos of phi minus r sine theta sine phi dot. So let us multiply this. So it is r dot, this with it, and then sine theta, so it is sine square theta, and it is cos and the cos, so it will become cos square phi. Then again r square, that is r square sine theta, it is r square, so a plus sign will be here, it is sine theta cos of theta and theta dot, and then cos square phi, and again it is yeah minus, it is r square sine square theta sine phi cos phi and the phi dot. Similarly we can calculate y dot, and that y dot can be written as r dot. I am just writing it directly, r dot sine square theta, it is sine square theta sine square phi, it is yeah this with it, so it is r dot sine square theta and sine square phi, and then again plus r square, so it is sine theta, it is cos of theta dot sine square phi, then plus r square, it is sine square theta sine square theta, it is sine phi cos of phi, and it is a phi dot. Then similarly z dot can be written as r dot cos square theta, r dot cos square theta minus r square sine theta cos of theta and theta dot. So let me sum up all these right now. So what it will be, it is because now this 1 2 3, these are the three equations, say one equation is this, 2 is this, and 3 is this, and say equation number 4 will be here, and equation number 5 will be here, and equation number 6 will be here. So what should I do? Yeah, let me sum up all these. So x dot plus y dot plus z dot. So if I try to look at this part, so r dot is sitting here, so it can be written as r dot sine square theta and here these are the two common terms, so it is cos square phi plus sine square phi, right, plus r dot cos square theta, this is the third term. I put these two together, and then this, yeah, it is cos square theta, and then this is r square sine square theta sine theta cos phi, yeah, both will cancel out, and yeah, and let us try to look at this part. So these are the three terms, I put these together, so plus r square sine theta cos of theta and theta dot cos square phi plus sine square phi, and third term will remain as it is, minus r square sine theta and cos of theta. So this is equal to 1 and this is also equal to 1. So it is r dot sine square theta plus r dot cos square theta plus r square sine theta cos of theta theta dot is also sitting here, minus r square sine theta cos of theta and theta dot. These two terms will cancel out. So here it is r dot sine square theta plus cos square theta. So that means x dot plus y dot z. So dot is equal to r dot. So I can write down from here that r dot is equal to x dot plus y dot plus z dot divided by r. So therefore this r dot can be written as x dot plus y dot z dot divided by r, or x dot y dot plus z dot whole divided by x square plus y square plus z square. So first part of this is proved. Let me go to the second part now. So for that, what should I do? First of all, let me draw a coordinate system. So this is a r. Let me draw a perpendicular from r to here. So it is x and it is y, and this part is known as rho. And if I apply a parallelogram law vector addition, then rho is equal to magnitude of this x square and the y square, and say it is r, and this is theta, and this is perpendicular, then rho over r is equal to sine theta. So their rho can be written as r sine theta. So this we have to remember. So now let me find it out. X dot and the y dot. X dot and the y dot. So what it will be? X dot and the y dot. So what is x dot? It is r dot sine square theta cos square phi minus r square sine theta cos of theta dot cos square phi, sorry, plus is here, it is r dot sine square theta cos square phi plus r square sine theta cos theta dot and the cos square phi minus r square sine square theta sine theta cos of phi and the phi dot, plus what it will be, y dot is r theta, it is sine square theta cos square phi plus r square sine theta cos of theta dot sine square phi plus r square sine square theta sine phi cos phi and the phi dot. And let me put these two terms together. So it can be written as r dot, it is sine square theta, and inside it will be cos square phi plus sine square phi. It is sine, I am mistaken, it is sine, let me erase it. So it is sine square, and here it is plus r square sine theta cos of theta theta dot, it is cos square phi minus sine square phi, and here it is r square sine square theta, it is sine it is sine phi, yeah, it is sine phi, right? Yeah, it is sine phi cos phi phi dot. So these two terms will cancel out. Yeah, these two terms will cancel out, and it is, yeah, it is 1. So it is 1 and it is also 1. So it is r dot sine square theta plus r square sine theta cos of theta theta dot, because what we are interested to find out, we are interested to find out r theta dot, we are interested to find out r theta dot. Okay, so it is basically, yeah, so that means x dot is equal to r dot sine square theta plus r square sine of theta cos of theta theta dot. So let us take r sine theta outside. So if I take r sine theta outside, inside it will be r dot sine theta and plus r cos theta and theta dot. So what is it? Sorry, it is y dot. Yeah, it is equal to this one. And let me bring it here. So x dot plus y dot divided by r sine theta, it is equal to r dot sine theta plus r cos of theta theta dot. And this is basically rho, so x dot, as this is equal to rho, so x dot y dot divided by rho is equal to r dot sine theta plus r cos of theta theta dot. But z is equal to r cos of theta, z is equal to r cos theta. So if you multiply both sides by r cos theta, basically, as we know that z is equal to r cos theta from this particular diagram, right? So this is z, so it is from here z comes out to be r cos theta. So if I multiply both sides by y dot into, yeah, it is r cos theta divided by rho equal to r dot r cos of theta sine of theta plus r square cos square theta theta dot. And what is this? This is basically z. So I can write down it as yeah, it is x dot plus y dot into z upon rho into z upon rho r dot sine theta and cos theta plus r square cos square theta. It is r square cos square theta dot. Let us do one thing. Because we need r theta dot, so for that what should I do? Say cos square theta is equal to 1 minus sine square theta. So if I put it here, means it is r dot sine theta cos theta plus r square 1 minus sine square theta and theta dot. So it is r dot sine theta cos of theta r square theta dot plus and minus r square sine square theta and theta dot. So we can take a, yeah, so it is xx dot xx dot plus y dot into z upon rho, and also let me do one thing. Say z is equal to r cos theta, so z dot is equal to r dot cos of theta minus r sine theta dot. So let us take r sine theta, so inside it is r cos theta, it is r cos theta, and this will remain as it is, yeah, minus r sine theta dot plus r square theta dot. So what is it? This full complete quantity is equal to z dot, and what is r sine theta? This r sine theta is basically rho. So that means x minus x dot plus y dot into z upon rho is equal to rho z naught plus r square theta. Let us bring it here. So x dot plus y dot multiplied by z upon rho minus rho z dot equal to r square theta. So simply I should write down it as yeah, x dot plus y dot into z upon rho minus rho z dot whole divided by r, and it will become r theta. Oh sorry, theta is here, theta dot is here, see, so it is r theta dot. I bring this r from here to here, so this is nothing but this is b theta. So this is the second part which we have proved. Now let us do little more algebra for the third part. So for that what should I do? So as we try to find out xy dot minus yx dot, and this is equal to, I'm not doing it, I am writing it directly, so it is r dot sine square theta sine phi cos phi plus r square sine theta cos theta theta dot sine phi cos phi plus r square sine square theta cos square phi phi dot minus r dot sine square theta sine phi and cos of phi minus r square sine theta cos of theta dot sine phi cos of phi plus r square sine square theta sine square phi and sine square phi and phi dot, right? And this simply will become r square sine square theta and the phi dot. See, r dot sine square this sine phi cos phi, yeah, this will cancel out with it, and this will cancel out with it. We will remain with these two terms. Say r square sine square theta phi dot can be taken outside, and cos square phi plus sine square phi will become 1. Means it is like this, cos square phi plus sine square phi, so it is r square sine square theta and the phi dot. So that means now we are interested to find out r sine theta and the phi dot. So what should we do? R sine theta is one term, and it is inside it is r sine theta and the phi dot. So it is xy dot minus yx dot. So I can write down simply as this, and this is basically xy dot minus yx dot divided by r sine theta is equal to r sine theta and the phi dot, and this is nothing but v phi, and r sine theta we have evaluated it as x square plus y square. R sine theta is rho, or you can call it as a x square plus y square. So therefore v phi is equal to r sine theta and phi dot. It can be written as xy dot minus yx dot divided by rho, or you can call it as xy dot minus yx dot divided by x square plus y square under the root. So this is the third expression which we have derived. So thus we have written spherical polar components of the velocity in terms of the Cartesian coordinates. So that's all for this lecture.